What is going on, my young Padawans? Today I will be going through a brief little demonstration on pH for you boys. First of all, let me kind of run through what we're working with here. On this table in front of me, you will see a kind of a mixed bag of different chemicals that really you can find over the counter. I easily could have raided Dr. Valor's chemistry closet, and I could have gotten, chemicals with fancy names that we can't even pronounce, you know what I'm saying? But for the sake of this demo, I kind of wanted to just keep it real, and focus on, items that you can find at home or in your kitchen or whatnot, you know what I'm saying? The next thing I want to go through is kind of on some of the equipment we'll be working with here. I have some, little beakers, some nice little pipettes, and most importantly, we're going to be working with, bam, litmus paper. Litmus paper helps us record pH, and has these nice little groovy, keys here, so I can see if something has a pH that is basic or a pH that is acidic. And if you recall from a previous lesson, if a pH is 7, that means it's neutral, right? If it's above 7, that means it is basic. Basic substances end in OH, or a hydroxide group, if you recall. And if it is below 7, that means it's acidic. And acids start with H, or hydrogen. So without any further ado, let's run through this bad boy, all right? Item number 1, water. You recall that water should have a neutral pH. And let's see what we got. Ready? You excited? Oh, there we go. Ooh. Neutral, right? How do I know it's neutral? You guys will look at the key, duh. And it's somewhere, right around 7, so easy peasy, right? That's why water is kind of like our control group in this wonderful little demo that we're going through, right? Now we have ammonia. Have you ever smelt ammonia? For the love of God, you shouldn't. It is a substance that burns, and it will burn your soul. All right, here we go. Ammonia. Oh man, we got magical things taking place. It's turning kind of green, almost blue, which means it is, yeah, you guessed it, base. How low can you go? All right, whatever. Vinegar. Now, on a serious note, I love the smell of vinegar. When I was a kid, my mom used to clean the house a lot with vinegar, so I guess I've always associated vinegar with the smell of cleanliness. Here we go, you ready? Ooh, oh man, we went from kind of green to red, which means, you got it, homeboy, vinegar is an acid. Yeah. Moving on, we've got baking soda. Now, baking soda is a powder. To kind of use a previous vocab term, it is a solute, right? So I put this solute, the baking soda, into my solvent, the water. I'm stirring it up. I got a nice little solution. Let's pour it on here. Oh, here it goes. It's turning colors. We got green in the house. And you got it. Green is it's a weak base, but it's a base. Yeah, you got it. Oh, another little thing I wanted to point out. Notice the white background, huh? That's a good science tip that we learned yesterday. Now we've got soap. I'm kind of running low here, so I'll just kind of wiggle it on there, make a little mess. And I didn't get much on there, but yeah, you can see it's turning green, similar to the baking soda solution. And what do we know about that? It's a base, which is consistent. Most soaps and detergents and whatnot are basic. And that leads us to CLOROX, which is bleach. Bleach, it's the stuff that you put in swimming pools and weirdos put it on their hair to go blonde. And here we go. Ready? Oh, we have a trend. We got all these bases in a row. Oh man, bam, CLOROX, bleach. And last but certainly not least is my favorite item on the table. When you see me in class, if I am not drinking coffee, I am drinking Diet Coke. And let's finish strong, boys. Here we go. Oh man, you got it. It's a little bit orangey, which means somewhere between 4 and 5 on our action-packed key of greatness. There you go. Diet Coke. I wanted to finish with this one so I could drink it. Peace, boys. Have a good one.